All right, ladies and gentlemen, today's topic is translations, reflections, and rotations. This is jumping into some geometry topics, and I think you guys have probably seen things like this, although they might have been called slides, flips, and turns. So by the end of the video today, you need to understand the characteristics of translations, reflections, and rotations. And this part's really important. You have to understand the effect they have on congruence. Congruence, remember, is when two objects are the same shape and size. They are considered to be congruent. Write this note down, please. Okay, so transformations is kind of the general term used to classify translations, reflections, and rotations. They are all considered to be transformations. And transform, let's think about what that word means. Trans, okay, that means across, like transport, to move something from one place to another. Form is well, it's form. It's the shape of things. It's how things are formed. I know I'm being a bad definer of words. I'm sick. Bear with me. So across form, it actually means change form. Transformations across form change the form of the shape. It changes the position of a geometric object on a coordinate plane. So coordinate plane, remember, is an XY grid. And let's say I have a triangle here. A transformation might change the position of the triangle and put it up here in this quadrant, quadrant 1. So let's look at specific examples of each of these kinds of transformations. A translation is a slide. So you're simply sliding an object from one place to another. Let's take a look at this dot, for example. If I were to slide this dot 3 up and then put it, let's say, 2 over, my new dot would end up, oh, whoa, what happened? Whoa, what's going on? That's weird. Okay, sorry. My smartboard is freaking out on me. So your new dot would be up 3 and over 2 right here. There's a special way that we label these transformations. Let's say this point right here is called point A. We would label this transformed point, this slid point, A prime. This is called the image, okay? Our original is A, and the image is A prime. That's with a little dash up there. Let's say we take this line and transform it by the same amount. We'll go up 3 and over 2 for the entire shape. So I'll take it, I'll go up 3, I'll go over 2, and there is my new shape. Notice that every single point in the shape goes up and over, goes up and over the same amount. So it's slid by the same amount for every single point. If this was called line BC, then this new line that we have, once again, the image would be called B prime, C prime. Okay, so that's how you're going to label these transformations. This triangle here, let's go ahead and take the same translation of it. We'll move it up 3 and over 2. Pardon me. If my original was D, E, F, my new triangle is going to be triangle D prime, E prime, F prime, okay? Because I have slid it up. It's going to be hard to label right there, but we'll say right there is D prime. So the original image, and then the original shape, and then the new shape is called the image of the original. All right, so a translation simply slides it. It doesn't turn it, flip it, anything like that. It just slides it up and over or down and over, anything like that. All right, next let's talk about reflections. Reflections are frequently called flips. You're going to flip it over a line or a point. Now, at this point, you are at this point in your education, you're going to be dealing more with reflections over the X or the Y axis. than you will over a specific line or a point. So I'm not going to ask you to do anything like reflect the object over the line y equals 2x plus 3. I'm not going to do that. That would be a little tough for you right now. But if I were to flip things or reflect things over an axis, how about I take this point, point A, and reflect it over the y-axis. The y-axis is the up and down one, remember. So if I look, I first need to ask myself, how far away is A from the y-axis? 1, 2, 3, 4. So if I'm going to do a mirror image, it has to be that same distance in the same line. 2, 3, 4. So this would be my point A prime. Now, in your work, you're not going to be putting these lines right there. What you need to do is be able to visually see it's 4 away, so A prime has to be 4 away. Let's look at this line BC down here. Okay? For this, I need to flip the entire object, but I can do that most easily by flipping the endpoints. B, you'll see if I'm flipping it over the x-axis now, you'll see B is 1 away from the x-axis, so I have to put B prime 1 away from the x-axis going the other way. C is 3 away from the x-axis, so I'm going to put that 3 away from the x-axis up here. So my new line, BC prime, is right here, connecting B prime and C prime, and that gives me my image of the original. And you can see it's the same line, it's the same length, it's the same shape, it's just in a different orientation, it's just reflected like a mirror. If we take this triangle here, and let's look first at this point, we're going to reflect this over the x-axis. This dot here will say, let's see, D, E, F. This dot E is on the x-axis, so when I reflect it, I always have to ask myself, how far away is it from the axis? Well, it's not far away at all. It's on the axis. So E and E prime are actually the exact same point. Because if you flip it, it's just going to stay right there if you put it up against a mirror. D prime, if this is D, that's 4 away from the axis. So 1, 2, 3, 4. I'm going to go ahead and erase A prime. You can leave it on your paper, but I'll erase it to make this a little more clear for you. So this point here is D prime, and then F is 4 away as well, so this is F prime. And that gives us our triangle D prime, E prime, F prime. Okay, and you can see it's just a mirror image. The last transformation that we have to deal with is a rotation. A rotation is a turn, and this is probably the one that people have the most difficulty with that I've noticed. Okay, what's going on? There we go. A turn is when, a rotation is when you take an object and turn it about a certain point by a certain number of degrees. Let's say 90 degrees, 180, or 270. Now, in most cases, this certain point that you're going to be turning it around is the origin, point 0, 0. So right here. Let's take this triangle D, E, F, and rotate it 90 degrees about the origin. And let's see what that would look like. We can think of a 90-degree turn as a quarter turn, okay? You're moving it 1/4 around the origin. My suggestion for how to deal with this is take it just 1 point at a time. This point E is 1, 2, 3, 4, 5, 6 marks down the x-axis. If I'm going to be turning this 90 degrees, instead of being down the x-axis, it's going to be 6 points down this part of the y-axis. 1, 2, 3, 4, 5, 6 right here. If I do that for each one of these points, hang on, this would be E prime. If I look at D, it's over 4 and down 4. So I'm going to kind of take it from the origin going down this way. This goes 4, and then I'm going to go out this way 4. And that's going to be D prime. Okay, I went right and down, and then I have to kind of, maybe tilt your head and think right and down, and you're going to go that same direction, that same distance to get to D prime. F is 8 out and 4 down, so F prime is going to be 8 this way and 4 that way. And that's going to give you a 90-degree rotation around the origin. So you've taken this shape and you've turned it 90 degrees. Just the same way, you could take and turn it 180 degrees, which would go and end up looking like this. That would be like a half turn. Or you could take it 270 degrees, which would look something like this. And you'd have a shape right there. So these are all different rotations of the object about the origin. We're going to work on rotations a lot because that's probably the trickiest one for most of you guys. All right, I'm a minute over on my video. I apologize for that. Here's a reflection. If the following object, let's call it A, was reflected across the x-axis, what would be the new coordinate point of its image? So I'm looking for the xy point of A prime. Okay? Go ahead and type that response into Edmodo, and I look forward to reading what you guys come up with. Have a good one. Bye-bye.